Hi viewers, in today's video again we'll be differentiating all of these functions. The first one being y equals x raised to power 6 minus 4x everything raised to power 8 sine 3x, and the second one being y equals x6 sine 3x, the last one being x squared times x squared minus 1 raised to power 3. So let's just get down to business. For the first one, if you observe very well, we have functions of a function. That's for the first one, because I have a certain function raised to power a number multiplying itself with a trigonometric function. So this is a product rule, but I'm still having chain rule in it. So since we've already known how to do the shortcut to do chain rule, we'll just make it more simpler. Let's start from the first one. Y is equal to open bracket x6 minus 4x raised to power 8 times sine 3x. You can decide to pick your u to be sine 3x, or pick your u to be this. But as for me, I'll be picking, let's say, let u is equal to open bracket x raised to power 6 minus 4x raised to power 8. So that our du dx is going to be, bring down the power, which is 8 times, differentiate the inside. Differentiating the inside is going to be 6x5 minus 4. Then bring back the function as it is. Sorry, I'll complete the rest down. So bringing back the function, I'll be having x6 minus 4x. Well, I have to remove 1 from the power, which is 7. So this is our du dx. Let's still rearrange it. Our du dx is going to be 8 6x5 minus 4 times x6 minus 4x raised to power 7. This is our du dx. That's if you simplify this. Our v, we said, v is going to be what is left, which is sine x. And what is our dv dx? Our dv dx is going to be cosine x. So now we have removed everything. Let's just put it in the formula. Since it's product rule, which is dy dx is equals u dv dx plus v du dx. So what is u? We said u is x raised to power 6 minus 4x raised to power 8. So I'll be having x6 minus 4x raised to power 8 times, I'm multiplied by the derivative of v. And derivative of v, which is dv dx, is what? Cos x. So I'm having cos x, then plus, I have v. What is v? We said v is sine x. So I have sine x times what is du dx? We said du dx is all of this. So let me just let me write open bracket, because I'll write the whole of it here. I have 8 open bracket 6 x5 minus 4 times x6 minus 4x raised to power 7. So this is that I'm done with substituting in the formula. The only thing left now is for me to arrange everything. So rearranging this, I'll be having open bracket, let's write cos x first, sorry. Let's bring this back. I'll be having cos x times, I'll be having x raised to power 6 minus 4x raised to power 8. That's for the first part. Then plus, same thing with this, sine x, open bracket, I'll bring the whole of this inside. Let's see, 8 open bracket 6x5 minus 4 multiplied by, this should be down, x6 minus 4x raised to power 7. Now there's something we can actually do to this. I'm still having something that is common. Remember, I have x raised to power 6 minus 4x. I'm still having it here. This one is raised to power 8. This one is raised to power 7. That means I will pick the lowest of them, which is what? 7. That's I just want to factorize this out. So this is open bracket x raised to power 6 minus 4x all raised to power 7. I'm removing the lowest, which is 7. Open bracket. Now if I remove 1, since I remove 7, that means I still have 1 that is left, right? So I'll be having cos x inside times 1 of these that is left, x6 minus 4x. Then I'll be having plus, remember the whole of this is out already. The only thing left here is sine x and this 8. So I'll bring out 8 first, then sine x. This one is out, remaining 6x. Let me write it 5 minus 4. I will now close the whole of the bracket. You see, we've simplified things down. Had it been this one is still common, we can just solve it down. But I think from here, we can stop here and we don't have a problem. That's the derivative of the first one. So going for the second one, which says y is equals x raised to the power 6 sine 3x. This is still function of a function because I'm having my sign containing a certain function in it, which is what? 3x. So this one will still use the product rule. We say let u is equals the first part, which is x6, so that our du dx, du over dx is going to be what? 6x5. Sorry, this should be 5. Then now what is our v? V is going to be sine 3x. So how do you get the v dx? The v over dx, if you use your chain rule, you can just get it. But since we know how to do the shortcut of it, is differentiate the inside, which is going to be 3. You write 3. Then differentiate the whole of the function, not minding the degree. So the angle in it. So I'll be having derivative of sine is what? Cos. So I'll be having cos, but I'll bring back the angle, which is 3x. So the v dx is going to be derivative of the inside, which is 3, times the whole derivative of sine x, which is cos, and I'll bring back my angle. So having this, I'll just go straight and substitute in my formula. The product rule, which is dy dx, is going to be, we said u dv dx plus v du dx. So our dy dx is equals, what is u? We said u is x6. So x6 times what is dv dx? dv dx is 3 cos 3x. So I'll be having 3 cos 3x, then plus, what is v? We said v is sine 3x. So sine 3x times what is our du dx instead. I'm having du dx, which is going to be we said 6x5. So now we've not balanced things up here. We have to clear things up. This is dy dx is going to be, let's bring out this first. Let's say 3x6, then cos 3x, plus this one should come first, which is 6x5 sine 3x. So from here you can see that we have x6, we have x5, and 3 and 6, there's something common between them, which is what? 3x5. We can just pick the lowest term of the x, which is 5. I'll pick the factor of 6 and 3, which is 3. So this is going to be, we have dy dx is equals 3x5. I'll factor it out. 3x5 open bracket. If I remove 5x, I mean x raised to the power 5 from x raised to the power 6, the only thing left will be just x. But remember, I've removed 3, so the only thing left here is going to be what? X only. So x, this should be x. Then I have cos 3x. I don't know if you get, because now multiply that. 3x5 times x is going to be 3x6, which is exactly what is here. So I'm having cos 3x, then plus, I factored out 3 already, so I'll be left with 2 here. So I'll have 2, but I've removed the whole of the x because I said x raised to the power 5 here. So I will not put any x again. I'll just have sine 3x. Now looking at this, in case you are confused of how I factorize, just multiply this back. You observe that you still have this, because 3x5 times x cos 3x, you are still going to have 3x6 cos 3x plus 3x5 times 2. That's going to be 6x raised to the power 5 sine 3x, which is the same as what was here. So this is the derivative of the second function, which is x raised to the power 6 sine 3x. Now lastly, for the third one, which is y is equals x squared times, we have x squared minus 1 raised to the power 3. This is still clearly product rule, but it's combined with what? Chain rule. So we say let u is equals just x squared, so that our du dx is going to be what? Just 2x. So what is v? V is going to be the last part, which is x squared minus 1 raised to the power 3. What is our dv dx? dv dx is going to be, bring down the power, which is going to be 3 times differentiate the inside, which is 2x alone. Sorry, this should be 2x. Then bring back the function, but remove 1 from the power. So I'm going to have x squared minus 1 raised to power 2. So I think this can just be simplified as 3 times 2 is going to be 6x, x squared minus 1 raised to power 2. That's the derivative of this. So we can put it in the formula, which is dy dx is equals u dv dx plus v du dx. So our dy dx now, substituting everything, is going to be u is x squared times dv dx. dv dx is what? We said 6x times x squared minus 1 raised to power 2. Then plus what is v? v is open bracket x squared minus 1 raised to power 3 times what is du dx, which is 2x. Now clearing things down, we're having dy dx is equals, this is x squared times 6x, that's going to be 6x cubed, open bracket, x squared minus 1 raised to power 2, plus the whole of this is going to be 2x, open bracket, x squared minus 1 raised to power 3. But something is really happening here. We have a lot of common terms. I have x here, I have x. 2 and 6, there's some, I can just factor out 2, because when I factor out 2, 2 can enter 6. So if I factor out this, I'll have dy dx is equals, if I remove 2 from here, but I'm still having x, so I'll have, let's factor out 2x. The only thing left here is going to be what? If I remove 2x, that's going to be 3x squared. Because 2x times 3x squared is 6x cubed. Then, open bracket, I'm still having x squared minus 1 all squared plus, now I will not put 2x again because I've already factored it out. I'll just put open bracket x squared minus 1 raised to power 3. Now I can stop here, but there's still something common. This is x squared minus 1, x squared minus 1. I can factor it out. So how do we do that? Lastly, dy dx is equals, we will have our 2x outside. I'll bring out the lowest of the two terms, which is what? Square. So I'll have open bracket, I'll have x squared minus 1 all squared times, I'll bring back this, which is 3x, open bracket, I'm still having 1 left here, which is x squared minus 1. Sorry, it shouldn't be here. We've already removed the 2, so I'll have just 3x squared here, then plus, I remove 1, remaining just single, which is going to be x squared minus 1, close bracket. We don't have enough space, so you can just complete this by, if you expand the bracket, 3x squared plus x squared is going to be 4x squared, then minus 1. That's the answer is going to be 2x, x squared minus 1 all squared, then 4x minus 1. Sorry, 4x squared minus 1. Thank you.